And the agenda is something as follows. I'm going to start by talking about the global estimates of climate change. Then I'm going to go on a quick detour onto the public discourse about the impacts of climate change. I'm going to talk about the distribution of impacts, and then I'm going to talk about what I did wrong, the missing impacts, and delve into the more recent literature on the empirical estimates of weather shocks. I'm going to try and reconcile what I started off with and that particular bit. And then I'm going to end with talking about the social cost of carbon. As you can see, this is quite a full agenda, and that is why I'm not going to talk about climate policy at all. Unless you want me to at the very end. I've scheduled 10-15 minutes at the end. So let's dive right in. What you're looking at is a complicated graph that shows all the published estimates of the total economic impact of climate change. And this is a complicated graph with many messages, but let me start by telling you what is on the screen and what is on the axis. On the horizontal axis, we have scenarios of climate change here measured by the change in the global mean surface air temperature. This is of course not that we believe that the global mean temperature is the only thing that matters, but this is just an indicator of the seriousness of climate change. So that is how you should read this particular axis. On the vertical axis, we have the Higgsian equivalent variation. That is to say, the way you should interpret these numbers is that if the world were to warm by 2.5 degrees, then the average person would feel as if she had lost 2% of her income. That's the average of the dots and squares that you see here. Now, it's not that she has lost 2% of her income, but she feels as if she has lost 2% of her income. So it is the Higgsian equivalent variation. So that is how you should read this graph, and then the dots and the squares and the triangles and the diamonds that you see in different colors are the 72 estimates that have been published in the academic literature on what climate change would do to human welfare. And the first sort of message that you get, the sort of suggestion that this graph creates is one of confusion. And some people think that is a problem. I don't think that at all. What we are talking about is what would happen over the next century or so, or maybe over the next 2 or 3 centuries. Predicting that far into the future is very, very difficult. And also we are talking about unprecedented climate change, definitely in the history of humankind, and probably in much of its prehistory as well. So the idea that you would try and estimate these things and that different people using different methods would come up with a very similar answer, if that would be the case, then something is seriously wrong with this literature. And unfortunately, that is not the case. There is a lively debate on answering this very complicated question. So the fact that experts disagree and disagree strongly, I think is actually a sign of health rather than anything else. Now, what do you see in this graph? The first thing that you notice may actually confuse you, and that is that we see positive impacts from modest warming. What I forgot to say is that I said that on the horizontal axis we have the change in the global mean surface air temperature. What I did not say is that 0 is pre-industrial time. So this is the year 1750. We're now already at, depending on who you believe, 1.1, 1.2, or 1.3 degrees of warming. So what you see is that according to some estimates, the initial warming may have been beneficial. Now that upsets some people because they want to believe that climate change is only bad. There's 3 big positive impacts of climate change. One, if it's warmer in winter, you need less heat to you need less energy to heat your home, and therefore you save money with climate change. The second is that fewer people would succumb to cold-related diseases, particularly influenza. And the third is the cause of climate change, or one of the main causes of climate change, and that is more carbon dioxide in the atmosphere. And carbon dioxide is plant food. And now that is probably a small effect, but if you have more CO2 in the atmosphere, then plants would also be more water efficient, and that is a much bigger effect. So those people who rely on agriculture in semi-arid areas actually see a boon from CO2 fertilization. So that explains the positive effects that you see in the beginning. But as I said, the graph actually starts in pre-industrial times, so these are actually things that are mostly in the past. They have happened already. If you move further into the future, the negative impacts of climate change will start to dominate. It is not that the positive impacts will disappear, it's just that the negative impacts are larger. And they would be that you would need more energy and therefore more money to cool your place, your home and your office in summertime. There would be more heat-related deaths, particularly cardiovascular and respiratory. The effects of climate change on agriculture are actually by and large negative if we do away with the CO2 fertilization. There would be a further spread of vector and waterborne diseases such as diarrhea and malaria. We would have sea level rise. There would be an increase in the intensity of storms. There would probably be more floods and be more droughts. And then a thing that is actually a relatively recent development in this literature, labor productivity would fall as well, and may fall quite substantially. So when it's very hot outside, there's all sorts of things that happen. If you're very young, less than 6 months, or very old, then heat can be deadly. But if you're sort of in between, and I assume that most of the audience is in their 20s, then a heat wave doesn't kill you, doesn't make you ill, but it does make you very, very tired. Now, it is not so much of a problem if you live in a air-conditioned house and you work in an air-conditioned office, but if you don't live in an air-conditioned house, then the nights can be taking their toll, and that means that the next day you're not as productive as you otherwise would have been. But for those people who work outdoors, farmers, construction workers, heat is actually a very big problem, and it simply slows down the human body. And that is a substantial toll on labor productivity. So those are the negative impacts that start to dominate for more substantial warming. Now you see a couple of strain estimates out there. The first two I'll talk about later. I think this is just a misspecified model. The third one is a funny estimate that was published by two very well-known, very well-respected economists in a pretty good journal. And what they use is a spatial general equilibrium model, and they make two key assumptions. One is they assume full capital mobility. So anybody would invest wherever the returns to investment are highest. And that is a pretty tall assumption in the short run. It may be more credible in the long run, but they also assume full labor mobility. That is, people can move around across the planet to wherever they would like to work or live. And what this model predicts is, as you know, eventually we all originate from Africa, and that is where the human species originated, and that is where from where we eventually moved into the rest of the world. In this particular model, we're all, by the end of the century, will be moving into Siberia, where by the end of the century you will have a lovely climate. And that is where the world economy will be concentrated in the future. if you assume full factor mobility. And that is actually a big boon to the world economy. If you're not prepared to make those assumptions of full factor mobility, then perhaps you would be less optimistic about the impacts of climate change. Now, as I said, this graph is pretty confusing. The gray line that you see in here is the Bayesian model average of 8 popular impact functions that are fitted to these data and then weighted as to their predictive skill. And I use this particular graph in the middle, the gray graph in the middle, to scale everything to 2.5 degrees, because that is where we have most evidence, and then this particular histogram results. And what you see is that the confusion in the previous graph actually largely disappears. Most of the literature, most of the estimates say that 2.5 degrees of warming would cost something between 0 and 2% of income, or would feel as if you would have lost 0 to 2% of your income. There is, as I said, a tail of positive impacts, but they are fairly small. Much more worrying is that the bad tail, the tail where you have negative impacts that are much larger than the central estimate, that is actually quite thick. So that is something to definitely keep an eye out for. But the central estimate is actually a fairly modest impact, negative impact of climate change. Now, whenever I say that, people get upset because this is not the message that they get from the media, that is not the message that they get from most of their politicians. I'm always a little bit surprised by this when lay people rock up to me by email or on Twitter or something like that and say that I got it all wrong. And typically these are people who have never published in this literature. Typically they are people who are not qualified to contribute to this literature in the first place, but they seem to know the answer of what climate change would do to human welfare. I'm always a bit surprised by the confidence of lay people on this very, very difficult question. But there's also more serious people, professionals, who claim that climate change is much more severe than the academic literature suggests. And they come in 4 groups, and they're listed here. The first is, of course, the environmental movement. Now, this is partly a matter of self-selection. You would not join an environmental NGO if you think that the environment is all rosy and dandy. The environmental movement attracts pessimists, definitely, about environmental issues. So that probably taints the message that they give. But then environmental NGOs by now are also large organizations, and they behave like all large organizations do. That is, their first interest is self-preservation and growth. And if you want to attract more donations, if you want to attract more members, if you want to have more influence on policy, you're not going to say that climate change is not a big problem, right? That is not how you attract new followers. Similarly, the media is primarily interested in selling copy and selling clicks, and you're not going to create a big splash by saying, well, yesterday's storm was just one of many and was nothing special. No, yesterday's storm was the storm of the century, and last week's flood was the flood of the century. That is how you maximize sales and clicks, by being sensationalist. Politicians also play a role in that. Politicians come in very different shapes and sizes, but all of them are looking for a legacy. And what better legacy than to have saved the world? And then, of course, you first need to claim that the world is threatened. And politicians also look for distractions. And the current Secretary General of the United Nations, Guterres, is a prime example of this. The first task of the United Nations is to keep peace between countries. That is Guterres' main job, and he is obviously failing in his job. And it's therefore very tempting to him to start talking about climate change, because that is at least something where there may be some glacial progress. But in his main job, he is an abject failure. Politicians, of course, also seek opportunities to reward allies and voters, and then in that sense they are allied with their civil servants. Civil servants are bureaucrats, and what bureaucrats do is they try to expand bureaucracy, and climate policy is actually one of the fastest expanding parts of bureaucracy around the world. And of course, that needs to be justified by claiming that climate change is a much bigger problem than it actually is. So that is why I think there is this discrepancy between the message that I just gave you, the message that is here, and the message that you get definitely in the Western media. I don't follow the media in Iran at all. Now, if this is the impact of climate change, of course, we cannot take away through climate policy all of climate change, but what we can do is take away a little bit, and realistically, without additional climate policy, we are heading for something like 3 degrees of warming. With additional climate policy, we can hope for 2.5 degrees of warming, and this is the benefit that would come from that. What you see, and this is a cumulative probability, what you see is that there's a small, very small chance that this would actually hurt welfare. Most estimates are actually on the positive side, but if you look at the scale of this particular graph, then you see it's a benefit, but it's a modest benefit, right? So far I've been talking about what happens at the global average, which is not particularly interesting because very few people live at the global average. So what I've done is I've taken these estimates that you see here, I shifted everything to 2.5 degrees, and then many of these estimates actually are not just for the world as a whole, but also have regional detail, and I use that to project to create this particular graph. On the vertical axis, we still have the Higgshian equivalent variation. On the horizontal axis, we're now looking at per capita income. So this is a cross-section across the world. This is the impact of 2.5 degrees of warming. And what you see is a very clear pattern. That is that the negative impacts are concentrated in the poorer countries, positive impacts are concentrated in the richer countries. Now, there's one thing that may puzzle you when you look at this, and that is that for the vast majority of countries, we see a negative impact and a fairly substantial impact. And the question you may have is, how on earth can this add up to -2%, right? If we add up all the dots, how do we end up with a global total of -2%? The reason for that is that previously I was looking at the impact on the average welfare on the planet, and I was using market impact, so I was counting dollars essentially, and essentially the global average is based on the principle of $1, one vote. So these impacts on the small number of rich countries actually dominates the much larger number of poorer people, right? So why do we see this pattern that we see, that the negative impacts of climate change are concentrated in poorer countries rather than in richer countries? There's 3 structural reasons for that. The first is exposure to weather and climate. In a country like the UK, lots of people work in retail or in publishing or in finance or things like that. That is, they work in offices. Whereas if you look at the poorest countries in the world, then 50% of economic output, 70% of the workforce is in agriculture that is directly exposed to the elements. and therefore much more vulnerable to climate change. That is the first reason why we see this pattern. The second reason is on this graph. I replaced the horizontal axis by the current temperature. And what you see is that the negative impacts are concentrated in hot places. The positive impacts are unsurprisingly concentrated in cool or even cold places. And the reason that you see this pattern is twofold. One, the biophysical systems on which we rely, the plants and animals that feed us, they are closer to their limits in hotter places, right? The second reason is adaptation. If you live in London or near London, as I do, and you wonder what would climate change bring, what would climate change be like in a city like London, then you wonder, what do people currently do in Bordeaux or in Marseille or in Barcelona, right? A comparable city that is a few degrees warmer than London is. And if you wonder how would we cope with the heat, then you would copy the technology and the behavior and the institutions of a city like Barcelona. So that is a relatively easy thing to do. If you live in the hottest city in the world, like Singapore or Jacobabad or Dar es Salaam, then adaptation to climate change will have to be invented from scratch, which is much more difficult than copying other people's behavior. So that is why you see this pattern pop up, this relationship with heat. And of course, it's also the case that hotter places tend to be poorer and poorer places tend to be hotter. The third reason is also related to adaptation. Adaptation is crucially important in the impacts of climate change, because we won't let climate change happen to us. What we will do is try to make the most of the new opportunities that a changed climate will offer, and try to minimize the negative impacts of climate change. That is what humans do. Now, a lot of that adaptation is private, but a good part of it is also public. If we're talking about such things as coastal protection, that is typically a duty or the task of the government. If we think about large-scale large-scale irrigation, that is simply that's often something that governments do, and of course, healthcare. The government also plays a very big role. Now, it is unfortunately the case that in poorer countries, the ability of societies to adapt is much lower, and we call that adaptive capacity in this literature. And adaptive capacity essentially depends on three things. If we're talking about, or maybe a little bit more, if we're talking about the public goods part of adaptation. One is that you need to have a government that is able to raise taxes to pay for dikes and irrigation canals and so on and so forth, and hospitals. Second, you need to have a government that is capable of delivering these infrastructure projects. That is, you need a government with capable engineers and good project managers and so on and so forth. And these things tend to be lacking in poorer countries. You also need to have a government that is basically honest. That is, that the money that is collected through taxes actually goes towards the public goods and doesn't end up in Swiss bank accounts or in London villas. And you need a government that actually cares about its people. That is, the powers that be actually want to provide public goods rather than steal the money for themselves. And all these things are in lower supply. In the UK, we often bitch about our government, but it's much worse, of course, in many poorer countries. And that is the third structural reason why you see that poorer countries are much more vulnerable to climate change than our richer countries. So, a quick stock take. Climate change is a problem, but the global average impact is rather modest. Second, the impact is much larger in poorer countries, but the most severe impacts of climate change are rather symptoms of underdevelopment and mismanagement. And that, of course, immediately leads to the Schelling conjecture, namely that economic growth and improved delivery of public goods in health, water management, coastal protection would take away much of the impact, much of the pain of climate change. So much for the first chapter. Now I'm going to briefly tell you what I did wrong. And the first thing that you need to take away from this particular part is that this histogram that I showed you are underestimates, and they're underestimates by a factor 4. And there's two main components to that, both a factor 2. And the first is that the impact estimates that I've been showing to you are all incomplete. Now, there's a whole bunch of studies, and they're listed here at the bottom, that show sectoral detail of the impacts of climate change. They separately estimate the impacts on agriculture and on forestry and on tourism and on labor productivity. But all of these there are 9, no, there's 10. All of these 10 studies have a different sectoral cover. That is, they all include some things that others exclude and vice versa. And that if you then use the sectoral impacts that are estimated in other studies to impute the number where it was excluded, then the following bars emerge. There's actually 9 studies because the average is here. So Fankhauser includes a good bit, but if you include in Fankhauser what the other people included, but Fankhauser himself omitted, then his estimate increases by 69%, right? And you can do that for all the 9 studies. And then the average is that 73% of impacts were omitted from the particular study for all sorts of reasons. But that is roughly the number that you should go on. So this is a rough doubling of the estimates that I showed earlier, and this is just by completing the sectoral coverage. The second reason why these impacts are off by a factor 2 is as follows, and this is a somewhat longer story. The estimates that I show here have been criticized for a whole bunch of reasons, and one of them is that they're mostly based on calibrated models rather than on estimated models. So over the last 10 years or so, starting with Melissa Dell, there's been an attempt to directly estimate the impacts of climate change using econometric methods. There's 2x2 strands in this literature. The first is the one that you're looking at here. And when I drew this graph, there were 8 studies that did this, but now I think there's 10, maybe 12. This is a rapidly growing literature. And what they do in this literature is they collect data for a large number of countries, and then they regress the growth rate of the economy, not on climate, but on weather shocks. What you see is, so on the horizontal axis, we have scenarios of climate change, starting with 1 degree of warming, ending up at 6 degrees of warming, and I realize that this is hard to read because the graphs obscure it. On the vertical axis, we're looking at the change in the annual growth rate of global economic output. And what you see is, again, a lot of confusion in this literature. Large negative impacts, but also positive impacts up to 6 degrees of warming, very substantial warming. Again, you see a very large discrepancy between studies. So people don't quite agree, again, because this is a very hard problem. But then when you actually start thinking about what actually do they find, it is large. It is very large. So this is not the change in economic output. This is the change in the annual growth rate of the economy. And it is not in percentage, it's in percentage points. So if we take the most pessimistic study, then what this says is that if the world were to warm by 2 degrees, and that may happen in the next few decades, then economic growth would slow down by 2.5 degrees, 2.5%. That is, if the economy currently is growing at 2% per year, this is the per capita growth rate actually, then at 2 degrees, we would actually be shrinking the economy by 0.5% per year. And if we go to 3 degrees, then actually the economy starts shrinking by 2% per year, right? And if we end up here, then we are really getting very rapidly to the end of civilization, as some people have predicted would be the impact of climate change. That is, we would all go back to hunting and gathering and scavenging. So these are very, very large numbers. Now, if you look at how did they actually do it, something very peculiar pops up. That is, they modeled the change in per capita income, that is the growth rate of per capita income. They regress that on the level of temperature. Now, that is peculiar. If you're an econometrician, then you know that you should never relate a flow to a stock, right? This is a level, this is a change, or this is a level, this is a rate. And relating levels to rates is always a bit tricky. And you should be very careful when you do that. So that suggests that econometrically this is just not balanced. The other thing that is peculiar with this specification is that if climate change were to stop, that is, temperature no longer increases systematically, it would be warmer than it is today. And that means that according to this particular model, economic growth would be permanently lower in most cases. The economic growth would be permanently decelerated, which is a peculiar prediction that these models make. And also, of course, if you start this model not in 1960 where you have data, but you start this model 1500 years ago or 5000 years ago, then what you would have is that warmer countries have always grown more slowly than colder countries. That is, the current pattern of income across the world is because of differences in climate. And there's very few macroeconomists who would actually be willing to defend this particular proposition. I'll get back to why I single out this green estimate by Colquhoun and Wentz in a few minutes. So this is an econometrically and theoretically strange specification. So some people have instead run a regression of the economic growth rate on the change in temperature. And there's 4 such studies, and what you see is again substantial differences between estimates, but much more importantly, you see that and this is now the rate of warming rather than warming, but it is equivalent. These numbers are the same. What you see is that the vertical axis has changed, and essentially we dropped 2 orders of magnitude. We added 2 zeros in front of the impact. And you see a negative impact of weather shocks on economic growth, but it's much, much smaller than what you saw in the first set of models. Now, there is one paper that I'd like to draw your attention to, and that is the study by Max Colquhoun and Leonie Wentz. And the reason that I draw your attention to this is because this is the central estimate that is used by the network for the greening of the financial system, which is a bit of a mouthful, but this is what the central banks across the world, across the Western world, believe climate change will do to them. That is based on this particular study, which, as you can see, is actually one of the more pessimistic ones that are out there. And the exact specification that Kalkul and Wens run is here. We have the growth rate of per capita income is a function of the change in temperature, as I think it should, but then they interact the change in temperature with the level of the temperature. And then they include country dummies and time dummies. Now, this is, of course, common practice in microeconometrics at the moment, that you use dummies to kill essentially anything that is not your variable of interest. But there is a very peculiar part of this specification, and that is that they have the change in the temperature, they have the interaction of the change in the temperature with the base level of the temperature, but they don't include the temperature itself. And of course, if you recall your econometrics, that is something that you should never do, because you don't know what this measures now, right? You don't know whether this is the temperature or the change in, whether this interaction attenuates the change in the temperature, or whether it attenuates the temperature, or whether it actually just picks up the temperature because it was not in there in the first place, right? Now, the reason that they do this is because they assume that this particular variable, that temperature, is constant. That is, they deny climate change, essentially. They say climate hasn't changed, this is constant, and therefore it is in the dummies, which is a slightly peculiar assumption that they make, because this T bar definitely is not constant over time. That has a number of implications. One is, what is, so the T actually matters here. So essentially what they have a model here of clock convergence. That is, different countries grow at different rates based on structural differences between countries, but that structural difference between countries is their temperature. Then again, we have this prediction that warmer countries grow more slowly than colder countries, which is a very dangerous assumption to make. This is a form of climate determinism that I thought we had put to bed 100 years ago. Econometrically, you also have a problem, namely that you have this base level in here. It should have been included in your specification, but it is not. And that means that the spatial pattern of temperature differences between countries, between climate difference between countries, is picked up by your country dummies. And your base level climate change, global warming, is picked up by your time dummies. And that means that your time and location dummies are correlated with climate. That is, your dummies are correlated with your variable of interest. And now that works perfectly fine in sample, but you can't use a model like this to forecast, because essentially as soon as you start forecasting, you lose your dummies. And that is behind this particular finding by Richard Newell and his colleagues Brian Crest, and I always forget the first name of Sexton. What they did is a cross-validation exercise. That is, they estimated 800 alternative specifications. They estimated it on the same data set, and then they left out either some decades from their time series and tried to forecast those decades, or they left out a number of countries from their panel and tried to estimate the model on what remained, and then try to forecast what what the results for those countries would have been. And they follow, they have 800 models, but there's essentially 2 times 400. Here we have that the growth rate of the economy depends on the change on temperature. Here we have that growth rate of the economy depends on the level of the temperature. And what you see is exactly what I showed you before, right? If we use these levels models, then we have a impact of warming on economic growth, but it's fairly modest. It runs from +2 to -6. Whereas if we use these growth models, then the impact runs from 60% to -80%, right? This is the accumulated impact at the end of the century. So these models just show much larger numbers than these models. And we also have actually, as I said, very large positive impacts, right? This essentially adds 50% to the world economy by the year 2100 because of climate change. Now, these are the forecasts of the models. This is a complicated graph. This shows you whether or not these models get through the cross-validation exercise. And because these models rely crucially on dummies that are correlated to a variable of interest, these models essentially, and that is what these graphs show, and I don't have time to take you through that, actually very rarely pass the cross-validation tests, whereas these models actually do that much more readily. So these models are econometrically and theoretically and empirically better than these models, and they foresee a much more modest impact of climate change. Now, can we reconcile this? The histogram that I showed you, these studies are essentially comparative static. That is, there's a big change in climate, one-off, and that's it, right? And then we compare the economy as it is today versus, or as it was in the recent past rather, versus what it would have been had the world been 2.5 degrees warmer. So these are comparative static, whereas these estimates are dynamic, right? And we need to be a little bit careful in how to compare comparative static to dynamic estimates. Now, if you have a comparative static, if you have a static shock on the economy, then you also have dynamic implications, because if your economic output is lower today, then you will consume less, but you will also invest less. And that means that there will be a lower capital stock next year, and therefore your output next year will be lower as well. So if we use these comparative static impacts and run them through a fairly standard growth model, then this is the implied impact on economic growth, and this is how much economic output would be lower by the end of the century. And what you see is that these static impacts and these dynamic impacts are the same order of magnitude. Now, this ignores the dynamic impact, so the histogram that I just showed you should be doubled again, right? You should double it because of the missing impacts, but you should also double it because it missed the dynamic effects. So that is the first conclusion that you see. Now, we have an implied impact on economic growth, and then we have these two empirical estimates of the impact on economic growth. And the levels models or the growth models are very, very, very pessimistic, right? The level models are much more optimistic. I showed you this before. If I blow up this graph, then you see that the comparative statics are actually not inconsistent with what I believe are the better econometric models of the impact of weather shocks. And that is reassuring that these numbers are actually roughly the same. Of course, the uncertainties are quite enormous for both numbers, so it's hard to have a firm conclusion, but it's sort of reassuring that we're in the same ballpark. So I've been talking about the total economic impact of climate change and its distribution as well as its dynamics. What matters for policy is not total climate change, but the impacts of climate change on the margin. That is known as the social cost of carbon. Essentially, the social cost of carbon is what happens to welfare on average if we reduce emissions by 1 ton, or if we emit 1 additional ton, right? Social cost of carbon can be thought of as the Pigou tax, right? This is a tax that we should impose on greenhouse gas emissions. This is a crucial number in optimal climate policy. It's a crucial piece of policy advice, so we should not be surprised that there are well over 300, perhaps even 400 papers that estimate the social cost of carbon. And this particular histogram that you're looking at is looking at over 12,000 estimates that have been published of this particular number, spread over 323 papers. And what you see is a histogram. You see there's a clear mode. You also see that there's a small number of papers that say, well, it's not a social cost of carbon, it's actually social benefit, but it's really tiny probability. And then what you see is that you have this very fat right tail. It's a highly skewed distribution, and it's skewed the wrong way. Yeah, I still have 14 minutes left, right? But I'll do my best. Okay, so this is the distribution of the social cost of carbon. And the important thing to take away from this is that the distribution is so very skewed, right? That is, that negative surprises are actually not at all unlikely. So I'm going to skip this particular bit and just wrap up. Economic impacts of climate change are in the order of a 1% income loss for 2.5 degrees of warming. This is completely at odds with what the environmental movement would like you to believe, but this is what the academic literature would tell you. I dropped my screen. That's where it is. Those impacts are underestimates. If you add the missing impacts, if you add the dynamic impacts, you should double it and double it again. And then if you add the uncertainty and the inequity in the problem, then actually you come up with a conclusion that climate change is a serious economic problem that for sure justifies emission reduction. That's all I wanted to say. Thank you for your attention.